Hello guys, the first example I am taking in the topic gravitational force is this one. The first example I am gonna ask you that we have three masses m, 2m and 3m, and I have placed them at a distance of r and 2r from each other. All of them are in a straight line and the distance between A and B is r and the distance between B and C is 2r. Now I want you to calculate the net gravitational force on B, the mass in the middle. I want you to calculate the net force on mass B. So this is the first question. The solution is here. So if you know the solution, you should pause the video and try to solve it yourself. Otherwise, the solution is pretty simple. All we need to do is, let's assign these forces some value. Let's assign these forces some value. The force on particle B due to A. Let's give it a name F1. I hope you know that gravitational force is always attractive. So the force from A on B will be in the direction of A. F1 is towards A. Similarly, the force from C on B will be, let's name it F2. Okay. So the force from C on B is F2. It is also attractive in nature. So it is toward C. Now let's calculate the magnitude of both the forces. F1 will be equals to G m1 m2 by r square. So this is the magnitude of F1. F1 I am calculating G m1 m2 by r square. It gives me 2gm square by r square. Now, this is what I am doing here. I am putting this gm square by r square as a single variable, a new variable f. This trick is useful when you have more than 2 or 3 or 4 force vectors. Okay, so the force F1 is basically 2F towards left. I know the direction. I know that it is towards left. Okay. The next force F2 due to mass C will be F2 is equals to G m1 m2 by r square. Here instead of r I will put 2r because the distance between 2m and 3m is 2r. So G 2m into 3m upon 2r whole square will give me 6 by 4, or should I say 3 by 2. We can cancel this out. This will become 3 by 2. 3 by 2 gm square by r square. So I will write it as 3 by 2 f. Okay. I know in my mind that this force will be towards right. Okay. Now F1 is greater than F2. We can see that. Although it is due to smaller mass, but due to distances, due to different distances, F1 is greater than F2. You need to realize it. The force not only depends upon the value of mass, it also depends the distance between them. So the force of smaller mass in this case is greater than the force of the larger mass. F1 is greater than F2. Now final result, net force. Net force will be F1 minus F2. Because F1 is larger than F2, so I will write net force is F1 minus F2. That will be 2F minus 3 by 2F and gives us F by 2. Now this is not the end of the question. You should write it that it is towards left because the leftward force was greater than the rightward force. So the net force is towards left. So when we write this in vectors, I will write net force as minus F by 2 I cap. Minus F by 2 I cap, so that minus indicates, this minus indicates minus direction. And our final answer will be minus gm square by 2r square I cap. I hope you understand this. It was pretty simple example. In the next example, I will talk about three masses but not placed on the same line.